Okay, sorry about that. Okay, so in the 5.3 notes, our first problem is going to have us review substitution. Now, as far as substitution problems go, this one, not a very nice one. We decided we'd solve for y in the top equation because when we move the 3x over and divide by 4, dividing by 4 is at least going to give us a nicer decimal than dividing by 3 or dividing by 7. You also could have said you want to divide by the 4 or solve for the y in the bottom equation. That would have worked as well. There's an extra negative you'd have to do, but that could have worked out just as fine. So we're going to divide by 4. And we're going to get negative 0.75 because that's what 3/4 is. And then negative 6 divided by 4 is negative 1.5. So at least the decimals aren't extremely difficult. Then we would take that equation. Remember, that's the top equation that we just manipulated. And we put it into the bottom. So every time you see a y, we would plug in negative 7.5x, because there should be an x there. Make room, there it is. And then minus 1.5. So bottom equation is now going to say negative 7x minus 4 parentheses, negative 0.75x minus 1.5 equals 14. And then we distribute. Connor, what number is in front of the parentheses that we have to distribute by? Negative 4. Excellent. Negative 4 times negative 0.75. If someone gave me 75 cents 4 times, I would have $3. Is that right? Okay, so this would be positive 3x. And what if someone gave me $1.50 4 times? How much money would that be? 6. Okay, so when we distribute here, we're going to get 6. Again, a negative times a negative is a positive. And again, a negative times a negative is a positive 6. Don't forget the minus 7x in front. I have to put a sign there between the two x's. And since 3 was positive, that's going to be a plus sign. And then I get this. Okay, so that's nice. There aren't any decimals anymore. I'm going to combine my like terms. Negative 4x is what I should get when I combine the negative 7 and the positive 3. Subtract 6 from both sides to get negative 4x equals 8. Divide by negative 4 to get x equals negative 2. Remember, substitution, all the work is front loaded, meaning you're going to spend more effort finding that first variable and then not near as much effort finding the last variable. I've already got an equation right here that is solved for y. So I'm just going to go ahead and use that. I could plug it into either of them or the one that I've already got that's solved for y. And so that's just going to be the easier option. 0.75 times 2 is $1.50 or 150. A negative times a negative is a positive. So y equals 1.5 minus 1.5, which means y is equal to 0. Is y allowed to be 0? Yeah. Remember, these are lines, and I'm trying to figure out where they cross. And they can cross on the x or y axis, or even at the origin. They could both be 0. Be glad you didn't get any of those on your worksheet, right? But I'm going to show you a way to do this same problem here in a moment that is about half as much work. Some systems of equations aren't set up for substitution. What do I mean by set up for substitution? What I mean by that is like the ones on your worksheet, for example, especially the first 3. You'll notice one of the equations is already solved for y. One of the equations is already solved for y. One of the equations is already solved for y. Here, none of the equations were solved for either y or x, but I could easily solve the bottom equation in number 8 for x. Like I could do that, right? Like, but these are definitely, the top 3 are definitely going to be easy for substitution. Problems like the last one we just looked at aren't as easy. So we're going to learn 3 ways to solve a system of equations. The first way we learned substitution. This second method is called elimination. Elimination can be used when both the x and y coefficients are the same, or better yet, opposites. Okay, put a star next to that one because that's the one you want. You want them to be opposites. Here are the steps for elimination. And I'll read through them and then we'll actually apply them so they make some sense to us. Choose a variable to eliminate. There's going to be some strategy involved in that, just like there's a strategy involved with choosing which variable to solve for if I'm using substitution. Add or subtract to eliminate the variable. Solve for the remaining variable, substitute that variable into either original equation, and then write your answer as an ordered pair. Okay, so let's actually apply that. This, by the way, is the same problem that we just did up here. So I want you to compare the amount of work we did versus the amount of work we're going to do. And we should, we'll have to check this, get the same answer of -2, 0. That's what we're shooting for. I wouldn't want to teach you a different way if it gave you a different answer, because that means something's wrong. So in this system of equations, you'll notice that the coefficient for the y variables, they're opposites. So I can make them cancel out or eliminate them if I add them together. Now, you probably have never thought about adding an equation to another equation, but you can. Make sure you're adding like terms. So if they have the x's where the y's need to be, and they're not lined up, you'd have to arrange them so they are lined up, because you can only add x's with x's, and you can only add y's with y's, and you can only add constants with other constants. What is 3x plus -7x? Christian? -4x. What is 4y plus -4y? Jimmy? 0. It's been eliminated. What is -6 plus 14? Someone other than Jimmy or Christian can participate. Lizzie? 8. So what is x equal to? Divide by -4. Shout it out. That's nice. It is equal to -2. I know that from doing the substitution, right? It's equal to -2. Now, I have to admit, before you start saying, why did he ever teach me substitution? There are problems where substitution is still going to be faster, and elimination would take longer. This is one of those where elimination will be faster. Now, whereas substitution is front-loaded, all the work is to get the first variable and then plugging in easily to get the second variable. Here, elimination is backloaded. You find the first variable very easily. Finding the second one takes a little bit more time. Okay, so now that I know x is -2, I have to pick an equation to plug x equals -2 in for. I don't think it's going to matter very much, but since these are smaller numbers, I guess I'll just go with the top one. So if I plug in x equals -2, I'll write it down this way the first time, and then obviously once you get the idea, you wouldn't have to write 3 times -2. You would plug in -2 for x plus 4y equals -6. What is 3 times -2? -6 plus 4y equals -6. To get y by itself, I have to get rid of this -6 over here. What gets rid of the -6? Adding 6 to both sides, a positive 6. Yeah. So I add 6 to both sides. When you add 6 to the left side and add 6 to the right side, it's just actually going to cancel out the -6. That doesn't always happen. It does in this case because remember, we needed to get an answer of 0 if we were going to have this correct, and I get an answer of 0. And so compare that work to the mess of work we did up here. This problem is set up for elimination, not substitution. Okay, so it's new. Let's do it again. In fact, I wrote the rules down for us again. Choose a variable to eliminate. Should we eliminate the x's or should we eliminate the y's? What would be easier? Xander?
The y.
Why do you say the y's?
Because they're opposites.
They're opposites. And what makes 2 opposite numbers go away or cancel out? Adding them together. Could you eliminate the x's? Yeah. How would you have to eliminate the x's though? Owen? by subtracting. Now, the reason I prefer them to be the opposite instead of the same is because adding integers is easier than subtracting integers. Okay? Adding integers in my head is easier to do than subtracting, and I can prove this because some of you made mental math mistakes on your last test, where you were doing x to the -6th over x to the -4th, and I was getting people to say x to the -10th, when in reality you're doing -6 minus -4, which is the same as -6 plus 4, which is -2. Do you see how you could mess that up kind of easily if you're doing mental math? Whereas adding, once I changed it to an addition problem, is much easier to do. So I prefer for them to be opposites, and so I would also agree with Xander. The y's would be easier to eliminate for that reason, because I like to add. Subtracting's for fools. Not really. What's x plus x? 2x. 3y and -3y will cancel out. What's -2 plus 16? Sky? 14. And Sky, what's that make x equal to? 7. You'll find the first variable very easily. By the way, I'm already on step, okay, we just finished step 3. We chose the variable that we wanted to eliminate, which was the y's. We added to eliminate that variable, and then we solved for x, which is the other remaining variable. We solved for x, take x equals 7. So now we're on step 4. Substitute that variable into either of the equations. I don't think one of them looks more difficult than the other. I'm thinking maybe the top one, just because it has smaller numbers again. So if x is 7, then I go up to the top equation. So there's still a substitution aspect here. Okay, you're going to be thinking, how is this different? Finding the first variable is the different part. You're still going to have to plug it back in to find the second one. And so 7 plus 3y equals -2. Subtract 7 from both sides to get -9. Divide by 3 on both sides to get -3. So x equals 7. Need to write my answers in ordered pair still. And y equals -3. And parentheses are important. Make sure you put the parentheses so I don't have to take a half point off. In this example, either variable could have been eliminated. To eliminate the y's, we added. To eliminate the x's, we would have had to subtract. Do I really need to do this? I guess I will. So when we added, we got 2x equals 14. If you would have subtracted, you would have eliminated the x's, because x minus x is 0. What's 3 minus -3? See, already you have to think about it a little bit harder. What's 3 minus -3? 6, because it's the same as 3. So in your mind, you might even be turning into an addition problem, which is why I like it adding instead. So you get 3 minus -3, which is 6y, and then -2 minus 16 is what? What is it? 14? No, that's not right. -2 minus 16. -18. Yep. Which will give us the -3 that we knew that we needed for our answer right there. Yes.
Instead of eliminating one variable and then plugging it into an equation, why don't you just eliminate both variables?
Great question. Why don't we just use elimination twice and be done? Because in most problems, both variables won't be set up for elimination. Only one of them will. So then you have to do a bunch of work to try to line the other ones up. At that point, you're better off just plugging it in. That's a good question, though. Yeah, Shane. Yes, where they have to be the same or opposites in order to eliminate them. Yeah, and that's what I'm saying. Like, not every question is going to have both of them already set up that way. Okay. You'll notice we had a name for this. We called the equations that were written like this standard form. And we called equations that were written like this slope-intercept form, right? So you see slope-intercept form, you know, something solved for y. go ahead and use substitution. You wouldn't want to have to rearrange it. Like, I can't use elimination on this the way it is because the X is on the wrong side of the equal sign. If I was going to use elimination here, I'd have to move the 6x over here to make it a negative 6x. I'd have to make sure the y is right above the other y. And then at that point, I've already done a bunch of work trying to get them to line up, and I still haven't got them to line up yet because the coefficients aren't the same or opposites. And so you can see substitution is still going to be faster on certain problems. I'm not completely writing off substitution. All right. Subtracting integers is harder than adding them, especially mentally. To avoid having to subtract, multiply an equation by -1. If you were dead set on trying to get the x's to eliminate, but you didn't want to subtract, you could have multiplied one of the equations by -1 to make it -x, -3y, and +2. It's perfectly fine. Follows the golden rule. What you do to one side, you do to the other side. That equation is the same. And now you can eliminate the x's. In fact, that's actually going to be really important for this one here. You could use subtraction to eliminate your x's, or you could times the bottom / top equation by a negative to make it -4y, -y, and -21. And then you can just add those together. That way I don't have to subtract. 4 plus -4? 0, no x's. -2 plus -1y? What's a -2 plus -1, Carson? -2 plus -1? Same sign, keep the sign. -3. And then 18 plus -21. -3. Divide by -3 and you'll get y to be equal to 1. Once you know y is equal to 1, plug in y equals 1 into one of those equations. How about the bottom one? Because there's nothing to times the 1 by. You plug it in right here. There's no coefficient for the y. So then, and by the way, I'm doing the original one. So let me go ahead and get rid of the minus signs. You could do the minus signs if you want to. It's just a waste of time. Plug it into the original one. 4x plus 1 equals 21. Subtract 1. And divide by 4. What's x equal to? 5. So I write my answer as 5, 1, parentheses, ordered pair. Yes.
So do the coefficients have to be the same in order to do this also?
Yes, because if they're not the same, then instead of one of the variables eliminating, they just become something else, and you actually didn't do anything at all to make it simpler. Okay, like this one that we're going to look at. If I just said, all right, let's add it, that's going to give me 6x plus y equals 17. And I didn't actually eliminate one of the variables. I just created a new equation that still has an x and a y in it. And the whole point is to get rid of one of them so I can solve. Okay. Which is a good way to lead us into our next point then. If there isn't a clear variable to eliminate, because like here I could tell it's definitely the x's I need to eliminate. I just need to make sure one of them is a negative so I could add. If you're good at subtracting with negatives, then subtract. I have no problem with that. But if there isn't a clear variable to eliminate, you're going to have to multiply or divide to align the variables. Multiply or divide to align the variables. For example, here there's the x's don't have the same or opposite coefficient. The y's don't have the same or opposite coefficient. But if I times the bottom equation by 3, I would get -6x plus +9y equals, and don't forget, you got to do it to the other side, 15. I wouldn't have to do anything to the top equation because what variables would be able to be eliminated now? My x's or my y's? It's not a trick question. Dig in. The x's. Yeah, I can eliminate the x's. So if there isn't a clear variable to eliminate, you can change one of the equations by timesing, in this case, by 3, and then you can eliminate the x's. To eliminate the y's, you would have had to have changed both equations. It's kind of like finding a common denominator, right? When I'm thinking like, what's my lowest common factor? 6 is my lowest common factor here, so I just have to change one equation. Here, if I wanted to get my y's to align, 12 is my lowest common factor. Lowest common multiple, not sure why I said factor. Lowest common multiple, LCM, you're familiar with that. It's the lowest common multiple. So I'd have to change them both by times in the top equation by 3, and the bottom equation by 4, but then that I just did 2 multiplications instead of 1. So be strategic when you're trying to get your variables to align. How about this second one? What could I do to which equation to make them to line up, person? By 2. Multiply the bottom equation by 2. Now that's going to give me a 4x and a 4x. If I want them to be opposites, make it a -2, and they'll become opposites. Okay? Or was anyone going to say anything else? Brady? That's right. The top equation, those are all multiples of 2. You could divide by 2, or I'll say times by 1/2, because we've done scale factors and you remember that's the same. And so that would give me, or -1/2. And so that would give me -2x, -4y equals -10. And then +2x still, because I'm not doing anything to the bottom equation. Now Carson's method is perfectly fine. I just figured I'd put an example in my notes here of dividing by 2 instead of always multiplying. How about this one here? Third one. Sorry, I know I'm not off screen. There we go. What could I do with this third set of equations to get the variables to line up? Alex? You could absolutely multiply the top equation by 4. My stylus does not work, or maybe it's my hands running into my screen. That's going to give us 4x plus 8y. And then I want to say, that's 56. Okay, so -56. And then -4x plus 10y equals 18. I'm not actually doing anything to the bottom equation at all. Now, you could make an argument. What if we times the top equation by 2 and divided the bottom equation by 2? That would work, but then you're doing 2 steps. So I try to keep it to 1. What about the last one here? We'll end with this one here today. What about this one? What would I do to make these variables align? Xander?
Multiply top by 2, the bottom by -9.
You could. You totally could. Now, this is an example of where I'm going to have to change both equations. There's no, I mean, doing the y's, getting the y's to line up, the lowest common multiple that they have is 30. So I'm going to still have to multiply the top by 6 and the bottom by 5. So either way, I'm going to have to change both. And so Xander's method here is going to give us -18x, +10y, and then 48 on the other side of the equal sign. On the bottom, +18x. So we want to add, that's going to work out nice for us to get rid of our x's. -54y, and then equals +99, and then I could add those. Okay. Other than that, everything else is the same. Once I got my variables to line up, then I do elimination, and that's where we'll stop for today, because I think we're getting out of here at oh wait, we have 5 more minutes. We could do a whole other problem, or maybe more. All right. Example B. We do have 5 more minutes, right? Yeah, we do. Okay. What variable should I line up? Deegan? Multiply the top by 2. Okay. So if I multiply the top by 2, that's going to give me 6x. Now, what if I want it to be a -6x? I could multiply by -2. You're exactly right. So -6x, -2y equals -22. The bottom equation, I do not have to mess with. Positive 6x, positive 3y equals 24. And I'm good to go. By the way, if you were thinking, can I just multiply the top equation by -3 to get the y's to line up? Absolutely you could. Maybe you were thinking I could divide the bottom equation by 3 because those are all multiples of 3. You could do that as well. There's more than one way to reduce a fraction. There's more than one way to get two equations to line up. Okay. Let's add. -6 and +6 cancel out. What's -2 plus 3y? -2y plus 3y. What's -2y plus 3y? 1y. And what's -22 plus 24? 2. Oh, that's nice. Y is 2. And if y is 2, I wouldn't mess around plugging into these equations, although I could. I'd probably go back into that original top equation because there's nothing to times the y by. And that gives us 3x plus 2 equals 11. Subtract 2 from both sides. What's that make x equal to? 3. So x is 3, y is 2. We did that one so fast. Now, hang on. We have time for another. I know what you're thinking. How is that's crazy. That's incredible. Well, that's math. It's impressive sometimes, you know. Okay. These equations are not set up for elimination. In fact, if I was doing it, I would use substitution because the bottom equation is already solved for y. But just to prove to you that you can use substitution on problems that are elimination favoring, or that you can use elimination on ones that favor substitution, you could use elimination the entire time if you wanted to, or substitution the entire time if you wanted to. I want you to use elimination on your 5.3 homework, and then you can decide what you want to do on your quiz. Okay, so I want you to get used to using substitution, elimination, then you can make an educated decision on which one you think is best. And I'll be honest with you, I'd go back and forth. Some are going to be better for substitution, some are better for elimination. What we're going to have to do, though, is make these in standard form. So we're going to have to move some stuff around. For example, we're going to have to move this x over to make it positive 2x plus y equals 3. And we're going to have to move this x over to make it positive 5x plus 5y equals 15. Then I'm going to have to change some things. Again, you're already thinking, why aren't we just using substitution? I know, I would use substitution, but this is elimination homework. So I'm going to just times the top equation by 5, but better yet, -5. To get -10x, -5y equals -15. Bottom equation, I'm not going to do anything to. So I guess you could say I'm timesing it by 1. Now, what variable did I just set myself up to eliminate? Sky? The y variable. Yep, I'm going to add. I'm going to get -5x. There will be no y's. And then -15 plus 15 is 0. And 0 divided by -5 is what? Still 0. So x is equal to 0. 0 is always my favorite number to plug in, because it doesn't matter which one I plug into. If I plug x equals 0, actually it kind of does. I would probably do the top one right here. What's 2 times 0? That's gone. So then I just get y equals 3. Perfect time. We'll look at one story problem tomorrow, and then we'll look at maybe some more. Well, definitely look at more story problems because we have a story problems worksheet to do in class. All right, see you guys later. All right. Should be in your 5.3 notes. Very bottom, story problem, says you buy 8 tulips and 15 daisies. Just notice that. For $193. Your friend buys 3 tulips and 12 daisies for $117. Write and solve a system of linear equations to find the cost T. Wow, what's going on? That was not there before. of each tulip and the cost D for each daisy. So we're going to use T for the cost of a tulip and D for the cost of a daisy. So we're going to have two equations here, one for you and one for your friend. How many tulips, Martin, do you buy? Okay, so 8 times whatever the cost of a tulip is. And daisies, you bought how many? 15 daisies. What are we going to do with those 8 tulips and 15 daisies? What would we be able to do for our equation here? Add them together and set it equal to what? That's right. So we have our cost equation, buying 8 tulips and 15 daisies. By the way, knowing that information isn't enough for me to determine the price of a tulip or a daisy. But if my friend buys them for the same price, which we're assuming they are, and my friend buys 3 tulips and 12 daisies for $117, then we can determine the exact cost of both. Now, this isn't our elimination homework, so we're going to use elimination. What's the lowest common multiple that we could get our T's or our D's to line up at? Person? Sure. Okay. So multiplying the top equation by 3 is going to get 24T. Multiplying the bottom equation by 8 is going to give us 24T as well. Or we could do -8 so that they become opposites and we can add instead of having to subtract. So that's going to give us 2 new equations. On top, we'll now have 24T. Help me out. What's, well, no, sorry, I know 15, but what about 193 times 3? Who's got that? Dawson? 576. You know, I'm just going to need more room. I thought I could squeeze it on that line, but I cannot. So I'll just write it over here. 576. And then on the bottom, we're going to multiply everything by -8 to get -24T. Get those T's to eliminate. 12 times -8 is what? Oh, sorry, 579. I misheard you. 579. Okay. What's -8 times 12? Sky? That's right. -96. And then 117 times -8. Who's got that? 117 times -8. Xander?
-936.
Okay. So we'll add these together. Our T's will eliminate. Our D's will not eliminate. I'll have a negative number of them. What will I get when I add 45 and -96 together? Christian? 51? -51, okay. -51D. What will I get when I add 579 and -936? That's another subtraction problem, obviously. Someone other than Christian. You need redemption? I'll come back to you. I'll let you be redeemed on the last part of it here. Yes. -357. Okay. And then Christian, back to you then. Dividing by -51 is going to give us what for the cost of a daisy? 7. Yep, 2 negatives make a positive. So $7 per daisy. Now that we know that D is 7, we can go into either of these equations in the red, or we could even use the ones in purple. I would avoid the purple ones because we made those bigger than they needed to be, just so we could get the T's to eliminate. And so it'd probably be easier to use the bottom equation in red. And so if we plug in 7 for D, we get a new bottom equation that reads 3T plus 12 times 7. What's that? Shane? 84 equals 117. Maddox, what do you get when you subtract 84 away from both sides? $33. Okay. And Emerson, what will we get for T then? 11, that's right. T represented the cost of a tulip, so $11 per tulip. And we have our answer. Now, as far as solving that system of equations goes, elimination wasn't extremely fast that time. And that's why I'm trying to tell you, like, elimination has its advantages and also has its disadvantages, just like substitution does. This is one that it probably would have taken us about the same amount of time and work, whether we use elimination or substitution. It wasn't set up for substitution. It was not even really set up for elimination because we had to manipulate the variables to get them to line up. And so this is where we get to choose. And I really wouldn't say there's a wrong choice here. Okay, so there's our elimination notes. And so now what I can do is maybe look at some 5.3 homework questions if you have any.